Okay, here's our topic, net ionic equations. And here's some important information. And here's our objective. So what we're going to find out is that when given a molecular equation, the net ionic is like simpler. It's like a reduced version of it because some things are going to kind of fall out. I'm going to define a bunch of things first. Like there's this complete ionic. That's basically all the ions that are there. All right. Whereas the net is only those that are really taking an active part in what's going on. All right. So one is like everything that's there, that's the complete one. And net ionic is the ones that actually change from start to end. And there's going to be these things called spectator ions. Spectator ions are ones that are there, but they fall out. They participate. Sorry, they don't participate, but they're there. They're often things that are really highly soluble, things that dissolve. Nitrates, alkali metals, group 1. You don't write them, and they're like a bystander. So let's look at an equation. And let's how do I write the net ionic? All right, the complete ionic. Well, to do that, you'd have to look at the things that are aqueous. If it's labeled as aqueous, well, then I'm like, okay, how do I those things separate into their ions? If it's not aqueous, in this case solid, it stays together. All right, so you can see that the only thing that was solid stayed together. All right, now this is just the same thing copied down. I want to look for things that are the same on either side. You'll notice that these B's are the same. All right, there are these B ions that are on both sides. There's also these C ions that are the same. All right, therefore these things will fall out of the equation, and I'm left with this. This becomes my net ionic. All right, and the B and the C become spectator ions. Here's another one. I've got barium nitrate, sodium sulfate, and they're making this two compounds. Now you'll notice if to do the net ionic, we got to look for things that are the same. You'll notice that these things here are the same. I got sodium on both sides and it's aqueous. Therefore, sodium is a bystander. It's a spectator ion. Here is my sodium nitrate. No, sorry, my nitrate ions. Those are also bystanders. Those are spectators. So that, and I canceled those things out. That means that I'm just left with the barium from the first compound, and from the second compound, I'm left with just the sulfate to become barium sulfate, and I'm the solid. And then the complete ionic is everything together. All right. Now here's another one. You'll notice that Ki is aqueous. That means it's going to separate it into its things. Ag is also aqueous. Therefore, it would separate into its ions. Now, silver iodide is not. It is solid. It's an insoluble salt. Therefore, it comes down and sticks together, whereas potassium nitrate, always soluble, those nitrates, then it becomes this. Now I look for my spectator ions. There's my first one, the K. Here's the other one, the nitrate. I didn't mean that to get blocked out on the right. But the nitrate and the potassium are my spectator ions. And so then the equation boils down to this. All right. Now, for a particular diagram of a molecular equation, let's Let's do this kind of slow. First, let's hydrogen. Okay, hydrogen is going to be represented by a purple circle. There's 6, so I'm going to draw 6. Now it's aqueous, so it's in solution. Chlorine's next. It's also aqueous. Iron is not. It's a solid. Therefore, it's going to be there at the bottom. Now, even though the charges of something changes, the color that where they represent is going to stick the same. The first one we're going to do is hydrogen. Now, I take in hydrogen. I take the 3 and the 2 and I multiply them to get 6 total and 3 molecules. I do the same thing sort of, except I've got 2 irons and 1 each. So, but they're in solution, and then I've got 6 chlorines. All right, and then now I'm ready to look at for the net ionic. This is the image you should draw in your notes. This image right here. All right, now you'll notice that these 2 grays here are basically identical. And so are all of these grays, all right? They're all basically the same thing. Therefore, they would kind of fall out of the equation. You'll notice I cancel them off in the one up top. Take them out. They're not part of the net ionic. So then this is what it would end up becoming, all right? That's the net ionic, where the chloride is the spectator ion. All right, let's do another one. Here we've got lithium. It's the gray circle. There should be 3 of them in there, and then they're aqueous, so they're like that. Hydroxide, its counterpart, is also aqueous. And the aluminum and the nitrate, there's going to be 1 purple and 3 whites. Now, in the after, we're going to start with this solid. Since it's a solid, it's going to be down at the bottom, all amassed together, and it's going to look like that. Whereas the lithium nitrate, it's an aqueous, so it just stays in solution. Now you'll notice we've got a lot of spectators here. Spectators are the gray and the white, so that becomes my net ionic, where just the hydroxide and the aluminum forming that massive compound. Okay, one more. Here is our molecular equation. I've got yellow is for potassium, beautiful metal. Lithium is green, good choice, and white is phosphate. And then I put them in. So I'm going to have 3 potassiums, one phosphate, and 3 lithiums. They're going to make 3 same, but except the yellows and the greens are kind of swapping spots. Now you'll notice these whites are kind of like they're basically the same. It hasn't changed. It's the same thing. Therefore, it would fall out of the net ionic. You'll also notice that there are 3 of each, so the whole equation would reduce to just this, where there's no coefficients. And my spectators are phosphate. All right, I hope that's helped.